Susan is a university music student studying to pursue her ambitions as a composer in electronic music. She has been assigned to compose a piece for class using the software available in school. Since she has to collaborate with others and compose at home, she wants to record and play music portably and in real time. She finds that the most affordable alternative is the SB404 from Roland, a sampler instrument that plays, edits, and records music. It was designed for music engineers to fit their technical knowledge, but because Susan is a beginning musician, her goals are to reach a stage where she can perform her own compositions, and thus she is looking for an interface that is easy to use, easy to learn, and can help her create multi-layered compositions for class and hobby. Unfortunately, the current system is very frustrating. Because it was designed for engineers, the problem Susan finds with this platform is that poor mapping and insufficient system visibility does not allow for differentiation of the main functions of the system. She has to constantly remember the sequence of steps she takes, and there is not sufficient contrast to make the system effective, leading to frustration and heavy cognitive tasks. We conducted an initial research to find out how users interact with the initial interface. We found from a group of Susan's persona that the cumulative tests for recording to playing a song takes a range of 8 to 18 minutes. Because we saw many errors in the study's use, we hypothesized that with proper design we can reduce this procedure by 50%. To verify the hypothesis, we would reduce the system features to just the main play and record features, itemize advanced features in menu, and improve system visibility with textual feedback. We created 2 prototypes satisfying the requirements we outlined. Prototype A follows the sequential narrative in which a sequence of screens gets you to where you want to play. Prototype B is based on more traditional operating systems and software. Prototype A focuses on just the main features of play and record and itemizes features in their own screen. This is influenced by gaming and control tablets specifically, but is better at targeting Susan's needs to have a learnable and fun interface that optimizes system visibility to instruct on what to do. Prototype B is influenced by other music software, has menu context and effects panels that are immediately visible, making Susan's goals easy to learn and the composing features immediately accessible. Both prototypes satisfy the requirements we set out in the beginning by making things effective, having a high utility and efficiency. Why does this work? The reason is because Prototype A provides direct pointing and reinforces strong pattern matching, while Prototype B organizes items using Gestalt principles and pop-up features to make playing recording options stand out. We conducted a usability study to determine the best features of prototypes A and B and compare them to the original design to evaluate future direction. We constructed a complete set of tasks to measure play, recording, and editing capabilities. We collected qualitative data regarding the visibility, learnability, and cognitive ease of those tasks, and our users showed that Prototype A was more learnable because the sequence told you where to go, and B was more explorable as the parallel features invited investigating them. The quantitative data we collected measured the efficiency and effectiveness of each task, calculating the mean time it took to complete them and the standard deviation. We used the standard deviation to tell us how far the sample uses varied from the mean to determine the effectiveness of each task. We found that the mean time for all tasks of A was less than Prototype B, and hence it was more efficient. The standard deviation, however, showed that the effectiveness varied with the task, thus A was more effective in playing and recording, but B was more effective at editing. We set out in the beginning to prove that our redesign could reduce the playing and recording times by 50% from the original. In summing all the tasks, we achieved that goal by reducing the total time for conducting all 6 tasks to 4 to 6 minutes instead of the 8 to 18 minutes of the original. The insight we gained is that the prototypes excelled at their features because of how they guided attention. Prototype A's navigation does not require direct attention, and that is why it is efficient. Prototype B is more effective in using controlled attention when composing music. In the future, we would combine the prototypes using the sequence of A with the parallel features of B in the composition screen to create an improved product.